Hi everyone, welcome to today's video. Today we will be discussing about models of DBMS. This is where we look at the physical architecture models of database management systems. Depending on your enterprise scale, budget and performance needs, you will choose one of three foundational models. Number one is Centralized DBMS. This is the oldest and most straightforward model in DBMS. Here the entire database application, the data itself and the data software sit in one single physical location, usually a single mainframe or a massive server node. So the advantages of this model is easy control and simple management. If you need to back up the data, update the schema or patch security, you only have one single machine to manage. And the disadvantage of this model is it introduces a catastrophic single point of failure. If a backhoe down the street cuts the internet line to that data center or server's motherboard burns out, your entire global business goes dark instantly. So to conquer the frailty of centralization, Big Tech created a distributed DBMS. Here, the database is physically scattered across multiple distinct geographic locations, say servers in New York, London, and Tokyo, all linked together by a high-speed network. To the end user, however, it feels like a single seamless database. So the advantages of this model of high availability and better reliability. If the London data center goes down due to a power failure, the New York and Tokyo nodes absorb the traffic. That's why users don't experience a single second of downtime. But it also has disadvantages like complex management. So keeping the data perfectly synchronized across global time zones in real time while avoiding conflicts is a monumental engineering challenge. Finally, we look at the undisputed workhorse of modern software engineering, the client-server DBMS. This architecture cleanly divides responsibilities between two distinct entities. One is client and second is server. The client. This is the front-end user interface, like the mobile app on your phone or the web page in your browser. The client's job is to handle presentation and request services from the backend. And now the server. This is the machine that houses the DBMS. It receives those incoming requests from the client and processes the complex SQL queries and enforces the data security and handles storage management. Because this architecture isolates presentation from heavy data computing, it is widely used across industries. You can see it running on banking applications, any other web applications, and enterprise systems. For the banking scenario, your banking app is the client and it securely talks to the bank's transaction infrastructure, which is a server. And web applications like e-commerce sites like Amazon, Flipkart, Shopify, etc. And the enterprise systems, massive ERP platforms allowing thousands of remote employees to access corporate databases concurrently. So to tie everything together, we use design approaches and ER modeling to understand our business logic. And then we use normalization to clean the structure, and we pick a physical DBMS architecture to deploy it to the world. So let's tie this back to our previous discussion on SQL languages. I want you to challenge your critical thinking. Imagine you are an engineer at a rapidly growing rideshare company like Uber. Now, if you are building a system to track real-time driver locations globally, would you lean toward a centralized or distributed DBMS architecture? And my second question is, if you need to add a brand new column to an existing table to track driver tip percentages, what category of SQL language from our last class, DDL or DML, what would you use to modify that normalized structure, DDL or DML? Let me know in the comment. Think about it. In the next video, we will be exploring the components of database engine like query processor, storage manager, transaction manager, buffer manager, index manager, etc. or database internals and architecture. So that's it for today. Thank you. Keep learning, keep knowing, and I will see you in the next video.